Welcome back to the second Byte of October, where we're going to learn about some of the different tile types that we have inherent in this module. We're going to look at the scripts that they're tethered to, how they work, and we're going to be able to construct a more interesting screen.
We are going to pick up right where we left off yesterday in talking about background tiles and collision types and things like that. We're going to add a whole bunch of new stuff. But more importantly than that, we are going to look at how it is tethered to the script underneath, glance at a little of the assembly code and talk through it a little bit, even though we're not going to go all that deep yet, but we will get there, I promise. We're going to add a second screen. So to do this, it's incredibly easy. Once you've opened up your project, don't forget, hit the little plus sign. That brings you back. You can hit the overworld, double click on your screen, and that brings you into that screen. So that means if you go double click on another screen, you're starting another screen. Now here, if I click on overworld in the map, you'll notice I can't get back to it. You have this fancy little overworld button at the top of the screen editor that takes you right back to your overworld. Also, something to keep in mind, overworld and underworld are a little bit of misnomers. It doesn't literally mean that your game has to have a Zelda-like overworld and a Zelda-like underworld. What it means is that you've got two maps that are 250 screens in size, 16 by 16. You'll notice we have some funny, weird things at the bottom, but we'll talk about that as we go. Basically, just understand that 256 is a very special number in 8-bit math. It is the highest 8-bit number that is possible. When you get to 255 and you add 1, it actually goes back to number 0. So the reason that we have maps of this size, we've got 16 by 16, that's 256. And we're going to, and so that's why our maps are limited to that size maximum. We have two maps. They could be, it's totally incidental what they are. It doesn't mean overworld, underworld. It could just mean, 512 screens in your game, and you can set them up however you want, and they can have any kind of relationship that you want. We're going to stick to the overworld quote unquote map for now. I'm going to double click on my second screen, and that's going to bring it up. And the first thing you're going to notice is you can actually see the screen next to it. And in fact, if you hit the left and right button, you can go back and forth between these two screens. If you hit the left and right button on your keyboard. And the reason that you see that over there is because you want to line the collisions up. You don't want your character to walk into a hurt tile or walk into a solid tile and be stuck in the wall. So we can actually start by lining up the basics of this. While I'm doing this, I want to really think about some game design principles. And one of those principles is teaching your player how to play. They won't even need any kind of manual. They're going to sort of learn how to play. Everyone uses Super Mario Brothers, the first Super Mario Brothers, as a shining example of this. And there are entire dissertations on the subject. We're going to teach our player how to play too, like what he's supposed to avoid and what he's supposed to get here on the second screen. Things we can interact with, things that we shouldn't interact with. But to start, let's do the simplest thing. Let's use that top of the ground tile, at least 2 tiles in, so that we're sure we don't get stuck inside of a solid collision. And then I'm going to use the 7 key again to draw ground underneath my feet. Okay, so now I've got some decisions to make. I want to make sure that the player knows that he can jump. And then one of the best ways I can do that is just by making a pit right here. That's going to implicitly let the player know that he's obviously got to get to this point, right? So if I walk, I'll fall down. Okay, let me try hitting the buttons and see if any of them make me jump. They do. Awesome. So now I know I've got to jump over that pit. So we've taught the player one rule of the game, which is that we're going to be jumping a lot with the A button. The next rule that we want to teach him is what he's supposed to be doing. What is the purpose of this game? And so since we've just learned the jumping mechanic, I'm going to actually use that as a secondary thing, for a secondary purpose, in letting him know that he can get a prize, but he's got to jump in order to get it. So I'm going to use my pink subpalette here and use this piece of candy. And I'm thinking if he's walking along here, he can't reach it. He can probably reach stuff that's this high if he jumps. So I've already jumped this, and I'm going to know, oh, okay, I can jump now. Yeah, I get it. I can jump and I can get that thing. It's obviously something I'm supposed to get. I'm supposed to obtain. I'm supposed to stay away from falling down pits. I'm supposed to obtain the candy. We are, after all, trick-or-treaters trying to get home from a long night of trick-or-treating with our candy bag. But of course, there are monsters and terrible things here in this world. The next thing I want to do is there's another type of tile that's this umbrella. And I couldn't honestly think of a better trampoline tile for this environment. So I made a pink umbrella. I don't know. We can always edit this later to make it something more interesting. What I'm going to do is I'm going to put a prize way out of reach. And there's no way that I can jump that high. And I know that. So, but what I want to do is I'm going to create a little divot here. So this is going to go down. Just gives my level a little bit more interest if I've got multiple levels instead of it all just being, flat. This is a little bit more interesting. And I'm going to put a tree over here. And I'll have it go all the way up. And I could, if I wanted to, suggest that maybe it's got, it's tall like this. That it's going off screen. And what I'm going to do is I'm going to use the branches, and they're kind of hard to see. They're sort of the second column, third row. These are branches. I'm going to use this branch like this. And maybe I can put one over here too, so it really reads as branches, right? Something like that. And down here, I'm going to put one of these pink umbrellas. And this is something that I can hop on. Now, your player is going to figure that out pretty quick. Like, okay, I can't get up here by jumping. This is too high in order for me to jump. By the way, if this isn't too high, we should remove this and put it a pixel higher. So we want to sell this idea that we need to learn how to play this game. So they're going to jump off of this, and they're going to realize pretty quick, oh, cool, that's something I can bounce on, and that's going to help them get up there, and then they can come back down. Okay, so that's, again, we're just trying to teach them how to play and the things that they can interact with and how. And now that I've got that, I want to go back through and I want to do some design work here and make it look a little bit more interesting again. I'm going to put these, I'll put some fencing back here again. I really like these trees in the background. I think it really makes a cool, gives me interesting depth with minimal tiles, and I can make one of them taller maybe, like that. And then I'll put some more mountains over here, like that maybe. And then, I don't know, maybe I'll have this mountain coming from behind instead of in front on the screen, like that. And I really like the warmth of my stars here. So maybe I'll add one here, one over here. And that's starting to look like a colorful, more interesting screen. Now we've got to go through and we've got to add collisions to this screen, and we're going to add a few new types of collisions. So I'm going to go and press on collisions, and then I'm going to come over here to solid. We already know that there's some places that we want solid for, so I'm going to put solid on these. And then I'm going to come and I'm going to put solid here. And notice I made sure that I put solid along the walls too. I don't want them to be able to fall into this space here. I want them to fall down to the bottom. But now I got a little bit of an issue. I want this to kill them. And right now, the way that this module is set up is that you get to the bottom of the screen, it takes you to the top of the screen, and it'll just sort of loop forever. And if any of you are curious as to why this happens, remember I was talking about 8-bit math. I was talking about 8-bit numbers. Well, your screen is 240 pixels, and there's an extra 16 pixels. It's 256 pixels wide, 240 pixels tall. So what happens is, as your player moves down, his Y value is increasing. It's going from 0, here it's 16, 32, et cetera, et cetera. It gets all the way to the bottom. It gets to basically here, and it gets to 256. And we know that that's a number that in 8-bit math doesn't exist. That translates to 0. So what happens if my Y value gets to 0? Where do I show up? Back at the top again. Same reason why in some games when you go off the right, you show up back at the left again. Our game engine has something where it checks to see if I've gone off the screen to the right or the left, and then it actually updates the screen, but it puts us at the 0 position on the next screen. It's still doing the same thing. We're just making a special case, and we're giving it some logic if it meets those conditions. We don't have any of those conditions for up and down in this engine, and you can use that to your advantage if you want to make a game where you have to fall down to the bottom and appear at the top. There's some cool puzzles that you can do with that, but for this game right now, that's not what I want. I want it to kill me. And so what I'm going to do is I'm going to use a hurt tile, and I'm going to paint underneath there with the hurt tile. Then I'm going to make sure that I use prize tiles for my prizes here. And I'll paint that with 0. And this one right here is a trampoline, but I'm going to show you a quick shortcut. If you have to just change a single tile, rather than paint it this way, which we've learned how to do, you can do that. Or you can right click on it, modify the attribute, and you'll see all your collision tile types come up here. I'm going to make this a trampoline. I could have done it the same way. I could have picked trampoline from here and then hit 0 over here. That would have worked exactly the same. But sometimes for spot checking, it's quicker just to right click and, choose your collision type that way. Now I'm going to put jump through platforms here and here. Jump through platforms here. And here, oops, not there, sorry, here. Put that back to null. All right, so now I've got a very simple little second screen that is going to teach me how to play. Not a hard screen again. We're going to get more difficult as we go. That's called escalating threat. It's another thing that we want to sort of think about when we're designing these screens. Notice if I click on my overworld button again, I'm still starting on this first screen. My starting position hasn't changed. And what's going to happen is when I get to the edge of the screen, it's going to take me to this screen. We saw in the last video that when I got to the edge, it just took me to a black void. It's because we hadn't made this screen yet. If we get to the edge of this screen, now we're in this black void that doesn't exist yet. But for right now, it's going to start here. If I wanted my character for some reason to start on this screen instead, I could right click somewhere, put place player. But I don't want to do that. So I'm going to go back to my overworld. I'm going to go back to this first screen. I'm going to right click where I want to start, place player. And I'm going to hit export and tenant. And now I'm playing through the game, and I've got that jump through platform here, and I move in, and you can see the screen that I set up. And if I fall down the pit, you can see it starts me over. And if you notice up here, I now have 2 lives. We have a very basic lives and point system. And also this is my ammo, which we're going to deal with at another day. But if I come over here, now I've learned, okay, I can't fall in that pit, so let me jump over it. Okay, now I know how to jump. Awesome. I can get that. Oh, look, my score went up. I got to get up there. I can't get up there. Okay, what's this thing down here? Is that something I can collide with? Okay, it doesn't hurt me. Oh, wait, maybe that can help me get up. Oh, cool, that can help me get up. See, so we're teaching the player how to proceed through the project. Oh, and I should have put a jump to platform there too. So let me fix that real quick. I'll come back in, and I'll look at my second screen. I'm going to press the right arrow key to move into the next screen. And I'm going to right click because I'm just going to spot check this one, modify the attribute into a jump through platform. Awesome. Okay. So now I've got a couple of screens. I've learned about some of the collision tiles. What I want to do is I want to kind of look at a few of these to see what's actually happening. We know what happened with this. When I touched it, it went away, right? It disappeared and it gave me score. And probably I'd want it to make a sound or something like that too, if I was really making a commercial release. This one, when I touched it, if I touched it from the top, it launched me upwards. It was basically like a super jump. So let me jump into the scripts for tile type. Let's take a look. OB and O8 and see what those say. All right. So let's go into my project settings, script settings, and I'm going to look at OB first. So if I look at my tile types and I look at OB, what is OB? Well, we're dealing with hex numbers. So hex values go to 16. They go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But instead of going to a 2-digit number then, instead of going to 10, which is 1, 0, they go A, B, C, D, E, F. And then they add the next place value. It looks like a 10. Really, that 10 in hex value is 16. If you do that math, it goes 0 through 15. But we can't say 1, 5, 15. We can't say 1 because we only have one place value. So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Then 1, 0 through 1F. Then 2, 0 through 2F. Then 3, 0 through 3F. 9, 0 through 9F. A, 0 through AF. B, 0 through BF. All the way down to F, 0 through FF. And then there's no more numbers, right? Well, guess what number FF corresponds with? 155. So if I add one more to FF, I go back to 0. Okay, that's a whole nother conversation for another time, but I just wanted to think about it. OB then would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, AB. There it is. And you can see this is pulling from the Adventure platform-based module tiles folder. There's one called Prize for the Arcade Platformer Base. If I hit Edit, that script is going to come up in my script editor. So the first thing that this does, now we don't need to know how to write assembly code to start looking at this code and basically figure out what it says, okay? I don't understand what this means, maybe you'd say, but I know it has something to do with checking something about the player. And if I think about this logically, it looks like it's either the player or it's not the player. So this must be checking to see if the object that's running into the tile is a player. BEQ is it's equal. So basically, if the register X, the object that's being read is a player, then I'm going to say it is the player, which is going to say I'm going to branch if it's equal to this label, which you can see where it's jumping to. The labels are working together. And if it is equal to the player, it's going to jump here. If it's not, it's going to continue on in code. And the first thing it does is JMP, you could probably guess, is jump. I'm jumping to a place in code, and I'm jumping to not player. So basically, I check to see if the object that's running this tile is a player. If it is, I'm going to keep going. If it's not, I'm going to skip all that stuff. So all of this stuff only happens if it's a player. And that's what we want, right? We don't want the monster objects to run into the prize tile and collect the prize. No, only the player can do that. All right. So the next thing is, again, you don't have to know this off the top of your head, and it's commented here so you can kind of understand how some of this stuff works. Change tile at collision. We need to change the tile where that tile type prize is. And what we get is the collision is going to change to, and the tile it's going to change to. I believe I have that order correctly. So what collision do we want to change to? Well, when I've collected it, it's going to change to 0 type of tile. So it's going to change to null walkable. If we look at what is my 0 type of tile, that was this one, null walkable. It's like all the rest of these. So we're changing it to the 0 type of tile. And we're also, I lost my, sorry, I can't pull that back up that way. Hold on 1 second. It's because I'm recording this, so it wants to be difficult. So let me come back over here to prize. Get back up. There we go. There we go. And it's also changing to the 0th tile. And if I looked at my tile set, I can see it poking on here. My 0th tile is the plain sky. It's the black tile. So when this happens, if I run into this tile and it is the player, the first thing it's going to do is it's going to change the tile into a null collision, which means I'm not going to be able to run into it a million times in a row. And it's going to change the tile to this on the very next frame. Frame to update 60 times a second. So it'll happen instantaneously to my eyes. The next thing it's going to do is it's going to do this add value macro. And this is a little bit more complicated, but let's take a look at it. The add value macro is looking for 4 arguments. It needs 4 pieces of information. And this gets a little bit more complicated into when we're dealing with multi-byte variables, such as the score value in this. The score, if I look at my game, let me pull up my game real quick. If I play the game, what you're going to notice is that the score has 8 place values. And in fact, the variable that we use for those place values, if I look at user variables, I have actually 8 bytes of data. And the reason that we're doing this is, number one, remember, numbers go 0 to 255, and that's it for an 8-byte number. So if I want to score that's bigger than that, I would have trouble. But there's another reason. We want to represent the score in decimal, even though we're using hexadecimal numbers in this 8-bit number system. So what that means is I want to show 0, 1, 2, 3, 4, 5, 6, 7, 8, and then I want it to go back to 0, and I want to increase the next place value. So think of this as now this is second hand, minute hand, hours. When the second hand gets to 60, this one goes up. When the second hand gets to 60 and this one's 59, this one changes to 0 and this one goes up, right? So what's happening is we're doing this weird cascading effect. We're using a different byte for each of these place values. And we're saying that when the add value macro is saying, when this gets to 9, if I add one more, this goes back to 0 and it increases the very next byte to whatever that is. If that one is at 9 and it increases the very next byte, etc. And it cascades through however many bytes are in the variable. So we need to kind of know that information. How many bytes are the variable? This one has 8. My lives only has 1. There's only 1 byte here. My ammo only has 1. So let's take a look at that real quick. If I come back over here and look at that again, I look at tiles, look at prize, edit. Okay, so I'm adding value and I can see all of these arguments that I need. So argument 0 needs to be how many place values this value has. Well, we just looked and we saw that we have 8 place values for this variable, right? There's 8 numbers in the score. There's 8 actual digits. There's 8 places, right? And this is the home variable. Well, the home variable is this one. Home variable is user variables. There you go. This is the home variable, my score, right? And I've got 8, and it's that followed by 7 more variables that are going to work with this one. So this is the home variable. I could also make a multi-byte variable, which is my score, and it'd be my score plus 1, my score plus 2. That's a whole other conversation. Again, we'll get to that another time. But the idea is this variable, I want to observe 8 place values. Here, sorry, I gotta keep doing this. And the next one it needs is, how much do you want that place value to go up by? I want that place value to go up by 1 when I collect this. Now, this is the one that throws everyone off. What place value is receiving the addition? If I put a 0, the ones place is receiving the addition. So that if I think about it like this, here's my score. Here's what my score looks like on the screen. 6, 7, 8. If I put a 0, this is the byte right here that's getting the update. So it would add literally 1. If I have a 1, this is the place value that's getting the update. This is the tens place. If I have a 2, if I have a 2, this is the place value that's getting the update. That would be the hundreds place. So if I wanted to add 100, I would say I'm adding 1 to the second place value. This is the 0th, first, second place value. So that would add 100. If I said I added 5 to the second place value, this would add 5 to this. If I said I wanted to add 5 to the first place value, that would add a 5 right here, which would be the equivalent of adding 50 to this, right? If I said I wanted 5 to the 0th place value, that would be this one, it would be the equivalent of adding 5. So go ahead, try changing the add value script to make this how many you want to affect what place value. 0, 1, 2, 3, 4, 5, 6, 7. Try making it add 1,000. Try making it add 20. Try making it add 1. Try making it add, try some different values in there and see if you can make what you're seeing in your head actually happen on the screen. So I want to look at that. I'm going to erase this and save that. Back to square. And then let's look at one other tile type that was a little bit weird, which is the 8th one, which was this trampoline. So this one is weird, and we want to talk about it, but you notice it starts the same way. We're checking the X register and we're seeing if it's the player. If it's not the player, then it's going to skip it. So it's only doing this stuff if it is the player. This means branch if not equal. So if I'm comparing the register to the player, if it's not equal, I'm going to jump to skip, which is here. If it is equal, it's doing all this stuff right here. Right? The next thing it's going to do is it's going to check. Look at that object's vertical speed. If it's equal to 0, that means I'm not moving up and down. If I'm not moving up and down, then I'm walking straight. I'm walking flat. So I can walk right past this. That's what I want. I only want this to activate if I'm falling downwards, right? If my Y value is increasing, that's the only time I want to activate a trampoline. This then says if it's minus branch, if it's a negative number, we also want to skip. So if it's moving in a negative direction, that means I'm jumping. I want to be able to jump through the platform and not have it affect me. The only time I want it to affect me is if I'm on the way down. So what I've said is look at the vertical speed. If it's equal to 0, don't do anything. If it's less than 0, if it's minus 0, negative number, don't do anything. That means the only choice that's left here is if it's a positive value, I'm going to load a certain value to the speed, the vertical speed, which that's the equivalent of jump. Now, where am I getting this number? That's the real trick. That's the real confusing part. Well, remember me saying that there's only 255 values for an 8-bit number. I want you to think about this for a second. This is a really sort of difficult concept to get your head around if you're unfamiliar working with this, but I think we can do this together, right? So let me look at this screen. Let me look at the first screen where the player is. If I moved at a speed of, let's say 16, okay? I would move 16 pixels the next frame, right? So the next time that a frame comes by, I would move from here to here. And the next frame, I would move from here to here. And the next frame, I would move from here to here. Okay, if I moved at a speed of 32, I would move from here to here, and then from here to here. If I moved at a speed of 64, that would be 4 tiles. 1, 2, 3, 4. So in one tile, I go from here to here. And then I go from here to here, basically, right? So what's happening is my x is increasing by a positive value. Okay. Eventually, though, what's going to happen? If I move at a speed of 240, if I counted these all up, this would be 16, 32, et cetera, et cetera, et cetera. That would loop me back around and put me right here. So if I moved at a speed of 240, if I added the position that I'm in right now to 240, I'd end up looping back around and coming right here. It's the exact same as subtracting 16, because I would end up with that loop. And the same thing, if I was here and I added 240, I would end up here. If I was here and I added 240, I would end up here. So effectively, adding 240 is the exact same as adding negative 16. It means exactly the same thing in 8-bit math, because I'm not looking at all the positions along the way. I'm literally adding to the number, getting the result. So if I were to be at 255 and add 1, I would end up at 0 again. We can understand that, right? We can understand that flip. The same thing is true if I'm halfway. If I'm at 128 and I add 128, I'm effectively just subtracting, right? So if we come back to that script that we were just looking at, and I want to just look at that a little bit deeper, and I go into there we go. Look at this a little bit deeper. I'm going to write some code here just so we can understand what's going on. So if I were to look at the different numbers and what they equal to, if I were to say the biggest number that you can get is 255, remember? 255. That equals FF. That's the biggest number that we can get. If I go one more than FF, I'm back at 0. If I go one more than 255, I'm back at 0. Okay, so that would mean that FF, if I added FF to something, that would be the same exact thing as adding negative 1 to something. Okay? So those would mean the same thing if I added the value. So if I added 254, that would equal FE, which would equal negative 2. If I added 253, that would be the same as FD, which would be the same as negative 3, et cetera, right? And because if we look back at the screen, if we think about it, if I added exactly 250, look where my mouse is, don't look where the square is, but if I added exactly 255, it would end up 1 pixel less. If I added 254, it would end up 2 pixels less. If I added 253, it would end up 3 pixels less. It wouldn't quite get as far, right? The furthest it can get is 255 pixels. If I added 256 of this, it would be right back to where it started. So 255 would be 1 less than where it started, 1 pixel less. 254 would be 2 less. 253 would be 3 less, et cetera, and I'd start to sort of move back this way. What that does is, in understanding how that works, if I come back and I think about what F8 means, because that's what I said to do it, we could do the math on that. And we could say that when I load F8, I'm really loading negative 8, if I were to keep doing the math, which, and I'm loading negative 8, the equivalent of negative 8, into the vertical speed. That's going to make me move upward at a speed of 8, because down would be the positive direction for y and up would be the negative direction for y. So if I'm saying move upward at a speed of negative 8, or if I'm saying move at a speed of F8, that's basically saying move upwards at a speed of 8, move in a negative direction in a speed of 8 compared to where you are right now. And then I'm storing that value into the vertical speed, which is what's making my character jump. So I know that was a lot of really thick sort of look at a little bit of assembly code and how numbers are working. I hope that what that was a very easy, here, let's build a level, simple as things, but then also look at sort of what's going on under the hood and why it works. And hopefully we were able to actually make some modifications to the score and go ahead and change this number around and see what happens too. Change this number right here, change it to F4 and watch how you don't jump quite as high. Put FF and you won't jump quite as high. Put F4, I'm sorry, you jump even higher. Put F0, you jump at a speed of 16, you jump really high. So play with this number and see what happens and try and get a feel for how these numbers work. And this is sort of what we can do to make some instant gratification happen on the actual tool while starting to learn what's going on under the hood and learning at least how to read and modify the scripts that are already there. It's not so scary, is it?